Wrong wheel drive. Anti-driving according to Max Verstappen. Ironic considering he himself owned a FK8 Civic Type R. But in today's episode of Automotive X-Ray, we'll prove to you why the DC2 Integra Type R solves all the problems that often come with front wheel drive, such as understeer, torque steer, and no oversteer. In fact, its handling is so good that the legendary Japanese show Best Motoring pitted it against the fastest JDM cars at the time, such as the R32 Skyline GTR. Well, that's not what makes the DC2 Type R one of the front wheel drive goats. It's that 9,000 RPM rev limiter. Yes, you've seen RX-8s and even the GMA T.50 rev to over 10 grand, but in the front wheel drive, unheard of at the time and unheard now. Yes, you could say the newer turbo Civic Type Rs are blazing fast through either the Nürburgring or twisty stretch of deserted tarmac, carving corners like a samurai swinging his razor sharp sword in a dojo. But there's one thing they lack: soul. Take a listen. And from the tight transmission feel to the telepathic steering the DC2 Type R has, is no wonder it's considered one of Honda's greatest ever driver's cars. Anyway, let's stop waffling and get on to how each part of the Integra Type R makes it so good, starting with its engine, known as the B18C Type R. Bold, beautiful, ballsy, and balletic, all adjectives that aptly describe the B18C Type R. Before we get on to why this is one of the most fabulous 4-baggers ever, let's quickly go over power and torque, as there are many versions of the DC2R engine, albeit with different power figures. Let's just use the USDM stats: 195 horsepower at 8,000 RPM and 176 Nm at 7,500 RPM, with a rev limit of 9,000 RPM. And in the US, it was the most powerful engine per litre at the time, with 108 horsepower per litre. And here's the kicker: VTEC pun not intended. When we have a look at the bore and stroke of the B18C Type R, it's 81mm by 87.2mm, so it's an undersquare design that in theory should produce more torque than top end power. And whilst this definitely allows the JDM B18C Type R to make 21 more Nm than the B16B that was in the EK9 Type R, the real magic is in how they were able to crank out this much power for an NA 4-cylinder at the time, while still keeping it bulletproof. And there's a few reasons for this. The first one being the pistons and the lightweight, high-strength connecting rods. The high-pressure die-cast piston crown was reshaped to increase the compression ratio, which leads to more power, to 10.6 to 1 in the USDM spec or even 11.1 to 1 in the JDM spec. The cylinder head also went through an extensive rework process, including hand polishing the intake and exhaust ports and fitting lightweight intake valves, all of which allowed the Type R to rev all the way to 9,000 RPM. And to keep it reliable over hundreds of thousands of happy high-revving miles, the piston skirt is coated with molybdenum, and the engine has also been fitted with high-performance dual intake valve springs with an oval-shaped cross-section. Onto the building blocks. It's basically the same engine block as the B16B, and it's a pressure die-cast aluminium alloy block with cast iron cylinder liners. The crankshaft is made of forged high-strength steel with 8 full balance weights to reduce vibration at high RPM by 20%. And when you combine these design features with a special micro-polished surface finish on the crank journals, it's no wonder the B18C Type R is a bulletproof motor. Also adding to the bulletproof nature is an oil jet cooling system, which cools the piston undersides during sustained high RPMs. This specific cooling system has even been used in F1 cars in the 90s. And continuing on the theme of cooling, the B18C Type R uses an aluminium oil cooler, which is mounted on the engine block to allow for maximum cooling. Now, onto the juicy bit. VTEC! The VTEC system for the B18C Type R is pretty simple really. 3 cam lobes and 3 corresponding rocker arms for each pair of intake and exhaust valves, whilst the 2 outer cam lobes have a profile that focuses more on low speed torque. The middle lobe has a higher lift, long duration profile that focuses on high RPM power. So when does the VTEC just kicked in yo actually happen? 5700 RPM compared to 4400 RPM on the Integra GSR. Before we get into what makes this car sound so awesome, let's hit VTEC again on the Seacliff Bridge in Australia. Absolutely marvelous. Now to the exhaust system then, shall we? One of the big reasons the Integra Type R makes 195 horsepower is due to a very efficient exhaust system, with the flow rate being increased by a staggering 30% over the Integra GSR. This is as Honda have used a tri-Y header system, where the individual head pipes gently converge into a tapered collector to provide smooth flow with minimum obstruction. And to tie a great engine together, you need great throttle response. Luckily, we're running a cable throttle body here that's been increased to 62mm to allow for extra intake flow. So when you put your foot down, you get exactly what you expect, instead of modern day drive-by-wire when there's a second of delay before it actually gets going. Throttle response is also improved by the use of a lightweight flywheel coupled with a heavy-duty hydraulically actuated clutch. For the intake manifold, it's a single port cast aluminium design, which not only results in 3.2 kilos being shaved off, but also for more flow, meaning more power. We have an engine, but we need something so it operates at its best at any speed. So let's now talk about the transmission. Being lauded as one of the best manual boxers ever, you'd expect this gearbox to be quite special. Firstly, it features a different bearing design and clutch than the Integra GSR, and what makes it feel so iconic in the hands of Honda fans is that short stroke shift linkage. To cope with the high RPM engine, the Type R uses a uniquely integrated aluminium die-cast engine stiffener, so the vibration is reduced 22% compared to the traditional separate fore and aft fastening systems which were used in the 90s. Let's now have a brief look at the gear ratios. In classic Honda fashion, they are all very closely spaced together to keep the car in the VTEC power band. Now, if we look at the differences between the 96 spec and the 98 spec JDM cars, the 98 spec uses a higher final drive that keeps first to third even closer, but maintains the motorway comfort by using longer gears for fourth to fifth. Unfortunately, the other markets didn't get this special final drive, but hey, you can always go to the aftermarket. Anyways, let's now move on to another aspect of what makes this car one of the most special front-wheel drive cars ever, the dynamics. Let's start off with the steering. It's a hydraulic setup, which is a big positive when it comes to steering feedback, as there's a direct connection between the rack and pinion, but it also uses quite a unique power-assisted steering gear design. What's interesting about this setup compared to normal racks is that it varies the steering assist not by how fast you're going, but by how high your engine revs and the torque generated between the pavement and the tyre. The advantage of this system is that it gives better control over how much steering assist is provided, as well as giving more linear feedback when it comes to the lateral loads that the tyres feel during cornering. Like all DC2 Integras, the Type R uses 4-wheel disc brakes with ventilated rotors at the front and solid rotors at the rear. And for the tyres, they're a pretty narrow 195/55 R15 spec all around, with the aluminium wheels that are 15x6 having a 5mm greater offset than the GSR. But in 1998, the JDM DC2 Type R got 215/45 R16 tyres for even better grip as well as bigger brakes. Japan really keep the best for themselves, don't they? But there's a common theme that makes this car dynamically wonderful even as a front wheel drive car. No understeer, unheard of for front wheel drive. And one of the reasons why that's the case is due to a helical type LSD that's similar to the Torsons of today. What happens here is helical gears are used to bias torque towards the wheel with more grip, making it feel more predictable than viscous coupling LSDs, so you get more traction on corner exit. And the next reason is using equal length half shafts for using an intermediate shaft on one side of the transmission to essentially keep the length of the half shafts on both sides the same. If we look at the torsional twist equation, torque steer happens as the left and right drive shafts at different lengths due to the twist on each drive shaft being different. So when the half shafts are the same length, torque steer is basically gone when you put your foot down, as the forces in the contact patch of the wheels now even out. And with that, let's now move on to the quads and hammies of the DC2 Type R, the suspension. In classic old school Honda fashion, we're running double wishbone suspension all around. But here's the kicker. This car is front wheel drive. How many front wheel drive cars in history outside of 90s Hondas can you think of that's running front double wishbones? Yeah, pretty mad when you think about it. The 90s were truly an era where car manufacturers threw the kitchen sink and decided to innovate. Anyways, back to the topic at hand here. The front suspension here uses an L-shaped lower control arm, an upper control arm, a coil-over shock absorber, a stabilizer bar, and a performance rod, which acts as an A-arm cross brace to stiffen the front lower subframe. Pretty standard front double wishbone design, right? Now add a new aluminium shock tower bar, which complements the 24mm stabilizer bar that is equipped with ball joints instead of rubber bushings. When you combine this rod and tower bar, you get a pretty rigid suspension, which in the Type R does have its negatives, as I will touch on later in this section. Continuing on the front suspension, it uses twin tube dampers which are gas pressurized, and compared to monotubes which offer better damping on high speed impacts, twin tubes are a bit more friendly on rougher roads at lower speeds. But the reason why many owners find this car quite stiff is not due to the type of damping, but how much damping there is. In fact, for the front, the compression damping has increased by a whopping 115%, whilst the rebound damping has gone up by 70%. To make things even stiffer, the front damper mounting bushing stiffness has been increased by a staggering 500%. Now, they have a stiff suspension for track work, but what really makes this car not understeer is through using specially tuned compliance bushings within the L-shaped lower control arms. What happens here is the bushings will allow the front wheels to toe out while braking in the corner, so that the car doesn't feel unstable at the limit. But we're not even done there for the front suspension. Like the Mark II Focus RS in the Turbo Type Rs, the front suspension geometry has a negative scrub radius. This means that the Type R will basically not torque steer. Why is this, you might ask? This is as having a scrub radius, which is the distance between the center of the tire's contact patch and the intersection point of the steering axis, means that when a force is applied on or by the tire, torque is applied to the steering axis, meaning torque steer. Now, onto the rear suspension. It uses the same components, but this time you now have a trailing arm. The rear springs in the GSR have been changed from a straight rate to a progressive rate spring, so the spring is now stiffer during the entire rear suspension movement. Not only that, but the rear damping rates have gone up by 66% for compression and 31% for rebound. To reduce body roll, the diameter of the stabilizer bar has been greatly increased from 13mm to 22mm to help reduce body roll. Not only does it reduce body roll, but it also gives the Type R quite a unique lift-off oversteer character, as well, with the stabilizer bar being so stiff. To enhance rear wheel stability, the bearing span within the rear wheel hub has also been increased by 10mm. So with all of these suspension changes, it makes sense why this is one of the best handling front wheel drives ever. But that's not even the end of the story. That will be the chassis and underbody. First up, aero. The DC2 Integra Type R features a new chin spoiler and a new wing type rear spoiler, and the vehicle is 15mm lower in overall height than the Integra GSR. This is to achieve maximum aerodynamic efficiency, and another measure they took to achieve this is through using a one-piece integral bumper assembly to eliminate gaps between the bumper and the body that tends to produce turbulence and disrupt laminar airflow over the hood. Now, let's look at the underbody. Whilst virtually every panel besides the roof is constructed of double-sided galvanized steel, which would in theory mean less rust. Well, if you live in salted roads like a lot of Europe and America, these cars tend to rust out a lot. In terms of the underbody rigidity, the chassis is basically the same as the DC2 Integra GSR, but it's quite a bit stiffer due to lots of rear components being thicker, as well as added performance rods to the rear frame end and rear suspension lower arm. Let's now head into the concluding remarks. Overall, what are my thoughts on the DC2 Integra Type R? Whilst the new FL5 Type R keeps pushing the boundaries of front-wheel drive in terms of lap times and performance metrics, to answer the question in the thumbnail, yes, the DC2 Type R is my personal front-wheel drive go, as it might not be the fastest, but listening to its soundtrack does give me the most miles. And you have to consider the FL5 has 25 years of engineering development thrown into it. That for me just makes the DC2 even more groundbreaking. Negative strobe geometry wasn't even that common on front-wheel drive cars until cars such as the Mark II Focus RS changed the game with its rev knuckle. Thanks everyone for tuning in and leaving kind words and incredibly helpful advice in the comments to help improve our automotive x-rays. Let us know what cars you want us to do next, and I'll see you in a bit.